In this video, we'll learn about carbon dioxide laser. At first, let us look at the symmetric stretching mode. In this mode, the carbon atom will not move, but the oxygen atoms will stretch along the axis of the molecule simultaneously. Both the atoms will stretch outwards and inwards simultaneously. So, this is the symmetric stretching mode of carbon dioxide. It is denoted as 0 to 0 state. Moving on to the next mode, the bending mode. In this mode, all the atoms, including the carbon atom, will oscillate in the perpendicular direction. If the carbon atom goes up, oxygen atoms will come down and vice versa. So, this is the bending mode of carbon dioxide and referred to as 010 state. The energy of the molecules in this state is the least among the three states. The last mode is the asymmetric stretching mode. In this mode, all the atoms will stretch asymmetrically. The oxygen atoms move in one direction while the carbon atom moves in the opposite direction. This state of CO2 is referred to as 100 state. The molecule has the highest energy in this state. So, these are the three different modes of the vibration of the CO2 molecule. When it is excited, it will go into any one of these modes depending on the energy. These vibration states play a significant role in CO2 laser. Now, it's time to learn about the construction of a CO2 laser. It has a quartz tube which is 5 centimeters long and 2.5 centimeter in diameter. The tube is known as the discharge tube. It is filled with a gaseous mixture of carbon dioxide, nitrogen and helium in the ratio 3:2:1. The gaseous mixture will be active medium for lasing action. Traces of hydrogen or water vapor is also added to this mixture. The tube has two discharge terminals which are connected to the DC power supply. Both the ends of the tube are fitted with NaCl Brewster windows. Brewster window is used to polarize the laser light. Similar to the other laser, we have two concave mirrors on either side. One of the mirrors is fully reflective while the other is partially reflective. This is the simple construction of a CO2 laser. Now, let us look at the operation. The nitrogen molecule in the active medium has the energy levels which are metastable. If we excite these molecules, it will go to its first vibrational state denoted as mu is equal to 1. Now, we know that the CO2 molecules have three vibration states. There is close coincidence in the energy level between the first vibration state of nitrogen and the asymmetric stretching state of CO2. This will help us in causing the population inversion. When the suitable voltage is applied across the terminals attached to the tube, we get a glowing discharge of gases. Due to this discharge, the electrons of many atoms in the active medium will become free. These electrons will move towards the positive terminal. In this process, few electrons will collide with the nitrogen molecule. Due to this collision, the nitrogen atom will go to its first vibration state. We can represent this process by an equation N2 plus E star is equal to N2 star plus E. N2 is the ground state of nitrogen. E star is the excited electron. N2 star is the excited nitrogen atom and E is the same electron with less energy. Here, the energy level of the excited nitrogen molecule is very close to the asymmetric stretching energy level of the CO2 molecule. Therefore, if a nitrogen molecule in the metastates collides with CO2 molecule in the ground state, the CO2 will get elevated to the asymmetric stretching level. This is because of matching energy levels and resonant energy transfer between the nitrogen and CO2 molecules. The nitrogen will come back to the ground state after the collision. This process can be represented as N2 star plus CO2 is equal to N2 plus CO2 star, where N2 and N2 star are the ground state and meta state of the nitrogen molecule, and CO2 and CO2 star are the ground state and the excited state of CO2 molecule. As more number of nitrogen molecules are elevated to the meta state through electric discharge, we get more number of CO2 molecules in the excited state. We can call this asymmetric state of the CO2 molecule as E5 energy state. Through this continuous collision, we can achieve the population inversion at the E5 state. That is, the number of CO2 molecules in E5 state will be more than the number of molecules in E4 and E3 states. Now, the CO2 molecule has two transitions. First one is from E5 to E4 state, and the second is from E5 to E3 state. The transition from E5 to E4 will cause radiation of wavelength 10.6 micrometer, which is in far infrared region. Similarly, the transition from E5 to E3 will cause the radiation of wavelength 9.6 micrometer, which is also in far infrared region. The photons released in the transition will be traveling back and forth in the active medium. This will cause stimulated emission of many CO2 molecules and the laser beam builds up. As the mirror on the right is partially reflective, we get a coherent monochromatic laser beam. This is the working of CO2 laser, where it produces intense IR laser beams. Due to its high power output, it is used in metal cutting, drilling, soldering, and other processes. It is also used in skin treatment and bloodless surgery. This is all about CO2 laser. To sum up, in this video, we learnt about the different vibration modes of CO2 molecule, the construction of the CO2 laser, which involves quartz tube, gaseous mixture, active medium, and Brewster window. After that, we learnt about the working, where we saw the pumping of the molecules through electrical discharge, the energy transfer between nitrogen and CO2 molecules, and the laser beam in the infrared region. In the next video, we learn about semiconductor laser. See you there.